I would like to introduce our final keynote speaker, our inspiration, the H in HANA, ladies and gentlemen, Hasso Plattner.
You are joking. Can you read the time? What can I say? There's nobody left anymore. Shall we bring in Dana? Wasn't it Dana? I think we have to do some jokes. Otherwise, Vishal, you talked about speed of HANA. I have prepared 13 questions. What? Customers prepared 13 questions. I should answer these questions. I basically have only one option now. We play the questions, and I say, didn't Vishal answer? It's an unbelievable opportunity for SAP to basically rewire the whole system. The systems we have built over the last 40 years, nearly 40 years. Next year it's 40 years. And Vishal and I tried to split up the time. You saw what happened. So he wanted to do the introduction in 52 minutes. That's what he promised. I will do it in 5 minutes, summarize it. So probably we rush through the questions. I try to speak HANA speak. Okay, let's try get the first question. Please roll.
My name is Vivek Sharma. I'm from THL Partners. We are a large Boston-based private equity firm. And several of our companies are interested in HANA. And my question to you, Hasso, is why invest in HANA? Why is SAP investing in HANA? What is your investment thesis about investing in HANA?
Henning and I were talking probably once a week about what do we do in the future? How do we move the 400 million lines of code of the SAP suite forward? There were two major ideas. We reprogram it, and we call it business by design, and probably we can reuse that. And actually, time for the merger of business by design and the suite was last year. So we missed that one. It was also not HANA speed. Business by design is doing well. We heard this, 500 plus customers. It sits in the cloud. It's doing its job. We cannot run, most of you guys, with business by design. We cannot run an Exxon. We cannot run an IBM, an HP, whatever you name it. These are in a different league. The business suite is in a different league. So what do we do with the 400 million lines of code, probably approaching 500? We didn't actually know. Stonebreaker from NIT said, you cannot change this anymore, in a conference in Providence, Rhode Island. And I replied, if SAP can't change it anymore, SAP will die. Last year, we announced we have a way out. And it's non-disruptive. If we build this HANA, if we start with business warehouse, if we take everything you have done, or some of you have done with business objects, so anything in reporting, analytics, anything in planning, we are feverishly working on a new suite of planning applications. If we bring this to HANA, this is a lot. And then we take out of the suite all applications or all application groups which have time-consuming runs, payment, dunning, scheduling, APO, ATP. Take this out, and run it on the high-performance base of HANA. Then the suite can shrink and concentrates on transactional business, workflow, the actual interaction with the hundreds and thousands of people in a company and outside a company. So we shrink the suite, we take away what we can do better on HANA. That's the idea. And therefore we are investing, it's the biggest project in SAP in the last more than 10 years. Extremely promising, and it's the biggest opportunity for SAP to provide new services to you, and it's the biggest opportunity for you, our companies, our customers, to optimize the business. I think after R3, which had a huge impact around the globe, you can already see what the potential of HANA is. It's totally global from day one on. I'm really pleased to see, first of all these brand names, and second, it was all over the world. India, China, Europe, America, everywhere. Fantastic. With HANA, SAP can solve the big data problem. We were not able to solve this before. For the first time, we can really work on nearly all structured data in a company and on unstructured data. We will talk about this in a second if we still are here. Or you, I will be here. So, next question, please.
Hello, Hasso. Suja Chandrasekharan, CIO of the Timberland Company. Very excited about HANA. What specific business needs can be addressed with HANA?
I think we have seen this. You get inside in real time a large amount of data. You can slice it and dice it by any means. We are not restricted by pre-aggregated data. We can put on the events which happen in the company and the ecosystem of a company. We can put on top of that any kind of hierarchy and roll up the data on the fly, in memory. We can empower users now because they can point and click and point and click, and you will get a different feeling with regards to your data. So no aggregates, no restrictions. Simplification. Actually, this is probably in our history a pivotal point where we did not produce more complexity, but really simplify systems. I will come back to that if somebody asks the right question. Next question, please.
Hi, Hasso. I'm Jim Noble, SVP and CIO at Talisman Energy. Hasso, what does HANA mean for non-disruptive innovation?
I can say here, I think, Vishal, you answered that. Step by step, no risk. HANA sits aside, no changes to the existing system, even going backwards to older system. And proof of concept is we can happily sit on top of an Oracle system. Anybody has an Oracle system here? Welcome. HANA works fine on Oracle. As I said, we will take over application from the suite step by step. They can run in parallel, and when you're comfortable, you can concentrate on using the new application on HANA and switch off the application inside the suite. And at length, Vishal talked about the gateway, how HANA can feed back information into the world of the suite.
Hi, my name is Tom Green. I'm the CIO of Colgate-Palmolive, and I was wondering why the HANA architecture is open and timeless.
Yeah, after nearly 40 years in software, and when you redo software, you know a little bit about layering and how you encapsulate things. HANA is close to the objectives Vishal gave us, or gave the company 2 years ago in an essay. We want to develop timeless software. So that means the pieces of software have to be relatively independent, and we can continue to change components without disrupting the system. That means disruption means we have to ship new versions and new releases. We want to be done with releases. We do not want to do releases in HANA. And the first proof of concept is there was a rumor, there's a 1.5 release, and the first customer said already, okay, that's good, then we wait. This is not coming. You can wait forever. 1.5 is not coming. All functionality which was planned for 1.5 fall this year or spring next year is already available at the end of June in the first general availability release of HANA. And then we will continue to improve the HANA experience by new mathematics, new algorithms, new front ends, but through the technique of layers in the system, this will come into the system on the fly. So if we add new libraries, this doesn't disrupt the system, so we will not ship new versions in new releases. Next one.
Hi, I'm Jerry Ebersol from Alcoa, and I was wondering what the TCO considerations are for HANA.
This is probably the best part. The hardware is extremely attractive. The hardware vendors, the hardware manufacturers, the component manufacturers are doing a fantastic job. Let's look at it. This is the smallest machine HANA is running on. An iMac Mini, 2 CPUs with 2 cores each, so 4 cores. We can run a company on this. There are 5 companies productively running in China on this machine. B1 is already running on NewDB. We have an unbelievable performance. Actually, when you ask the Chinese customers, how about performance, then they say, what do you mean? Response time. There is no response time. You can actually, there's a system outside somewhere on the floor, and the system is running there. There is no response time. I wish all our systems will, over time, achieve that response time they have. Congratulations to the Chinese development team. The next layer up in the hierarchy, this is a brand new blade. It's a little bit thick for a blade. The reason is, I don't know, does it have 2 terabyte or 4 terabyte memory? 2, thank you. And it has 80 cores. So 80 separate machines which can calculate, select data, what if. So 8 CPUs, 10 cores gives us 80. And then hyper-threading gives us 160 threads on one machine. And then we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we have 800. And if we continue, we have 1600. And if we continue a little bit further, then we beat the Watson from IBM. How could this look like? Yeah, we are in the league of the Watsons now with the high end. Can we get the little video? The other machine we couldn't bring here. There was a little risk with the truck and so on. We left it in Santa Clara. There it is. Go ahead.
Hi, Hasso. I'm standing here live at Bays Inc., which is one of our state-of-the-art colo facility partners. I'm sitting inside a cold aisle containment pod, and in front of us is one of the largest and most powerful HANA systems you'll ever come across. Here we have 1,000 cores, over 1,000 cores, 16 terabytes of memory, 64 terabytes of solid-state disk, and multiple 10 gig and 1 gig Ethernet interconnects. The great thing about this system, it also scales linearly. So if you need more cores or you need more memory, you simply add another node. One of the great things also is that we're able to take all of the advances over the last 25 years in technical and high-performance computing and bring those to the enterprise. With this system, SAP is at the forefront of the IT industry. So everything seems to be up and running just fine here. Everything's all green. So with that, I'll send it back to you in Orlando where I'm sure it's a little warmer and a little more quiet, I'm sure. Back to you.
Thanks. Thank you very much. This is a glimpse of systems which will be as cloud-like systems on your premises or inside the cloud of SAP and SAP's partners. Why is cost, despite these machines are so big and so much DRAM, which obviously costs money and the processors are not that cheap, why are the systems relatively cheap? Our footprint in data storage is so much smaller in HANA than in the suite or in any other system because of our compression. We compress non-SAP data round about a factor of 10, that's the average, factor of 10. SAP data, financials, factor of 50, manufacturing, factor of 20 at least, between 20 and 50. That means with 1 terabyte on this machine in a typical SAP ERP data environment, we can cover 20 to 50 terabyte of data. He had 16. He can go up to at least 32 on this machine. We don't know exactly, we will work out with our partners, what is the best combination of number of processors and memory. Memory size per blade has to be optimized, whether it's 1, 2, or 4 terabyte, we don't know yet. Next one.
Charles Baldwin with Cabela's. How reliable is data in memory?
That's a good question. How reliable is the system we run on today? In a highly tuned Oracle or DB2 based system or any other database, you can take MaxDB or Microsoft SQL Server as well. Most of the data is in a cache. It is in memory. And if the system fails, if you switch off the power, the system has to reload all the data from disk. Guess what we do in HANA? We reload data if we have a power outage. We reload it from storage. Now it is SSD instead of disk, so it's solid state disk, which is times faster. We replicate all data which is in memory permanently, or when something changes in a table, to the SSD permanent base, and then there is a layer of further archiving called RAID systems, so we use RAID for SSD. So we have the same data safety like today's hardware systems. It is just instead of having 90% of the data in the cache, we have always 100% of the data in memory. If we detect defects in memory, we can repair the blocks in memory from the SSD. If a whole machine comes down, we have in a rack, if we have 5 of these machines in a rack, one is idling and waiting that another one fails and takes over. And what I propose is an architecture we should look at with a duplex system that because the machines are relatively cheap, that we have 2 systems of the same size, that we try to build as much as a symmetrical duplex system as possible. One is running OLTP, both systems are running analytics, and if one system comes down, we still continue with the OLTP system and some analytics, and if the system is back up, we can accept the full load again. Data comes in from other systems, either through replication, this is online real-time replication from the ERP system, through data services, this is like ETL, triggered to some specific times, we copy the data, the delta, from other systems into the system, and feeds can come from outside, from anywhere. Next one.
Hi, Thomas Martin with GE Aviation. Would really like to understand why is HANA's applications, why do they function so fast?
Can anybody else be as fast as we are? Not at the moment. I kindly ask you, if somebody wants to do it, we are there instantly. Do a little Olympics in high-speed analytics. 1 billion or 10 billion or 100 billion rows, some medium or massively complex data sets with joins, etc. Actually, we have done this. Unfortunately, I'm not allowed to talk about it. I can only say 3 of the largest database manufacturers were asked to have a little competition. SAP was not part of it. And we came then in the finals against the winner. And we beat them handily. I cannot tell you how much, but it was very good. So why is it so fast? A HANA database is not one database, it's actually 4 databases. It's a row database in memory. This is like the normal DB2, Oracle, MaxDBs. It is a row database, but in memory. Then we have a columnar store. I talked about this at length last year, which is optimized for modern CPUs. Think about how we store data in memory. You always think we store data on a square or rectangular sheet. This is data storage. Data storage is totally linear. Totally linear. And if we store data in columns, one table, then one attribute is here. This is the next attribute, this is the next attribute, this is the next attribute, this is the next attribute. And we always process, in set processing, multiple attributes of one table. We search for a specific value. We search for a name. We search for an address. We search. Or we join data using a column. So the processing is always along columns. And when you take such a column and feed it into a modern CPU, L3, L2, L1 cache, the CPU likes that. So that's reason number 1. And you heard from Intel that we worked very hard to optimize this sucking in of data and performing the operations on the data we have inside. The second thing, you should not move this forward. Now, yeah, they moved it forward anyway. We work with minimal projections to technical compression. The compression rate I talked about. Since we compress data, we can access it faster. Very simple. Any attribute can be an index. We can write completely new algorithms. Algorithms can be much faster. My first one, I didn't write it, but I proposed how to write it. Dunning from 1,200 seconds to 1 second inside SAP. People ask me, why do you want to do this? Why does Dunning have to run so fast? One simple answer, it's just TCO. If it runs only 1 second, then it's 1,200 times cheaper. We can partition data. Most of the data, the huge data volumes you have, point of sales data. Point of sales data is, we don't change it anymore. It happened. So it's historical data, even if it's from just now. We can easily partition it, and then we can go along these machines here and have a whole battery of machines and run very large data sets of point of sales data. Map and reduce is a technology to run massively parallel across these machines. We showed you a machine with 1,024 cores. We can run one query on all 24,000 cores simultaneously, and then the query is very fast. It's done, and the computer is free. We have figured out how we do, this is for the remaining technicians here in the room, dynamic multi-threading within one node. We use the machine, if the machine is idling, we use the whole machine. If another transaction comes in or there's some load on the network, then we reduce the number of nodes which are working on the query. We are very elastic. So transactional processing has always priority. Short queries have always priority. If somebody runs a long-lasting query of 2 or 3 seconds, you can wait another second. There's no problem. If you want to do a fast application like the ones we have on the B1 system here on this little mini Mac, and you want to have something in the 100 millisecond range at least, or 50 milliseconds, you have priority and you just go through. We talked at length that we do not materialize anymore. We just work on events that frees us up completely. After 40 years, or actually it's already more, 45 years, in enterprise computing, I'm done with aggregates. Aggregates are a virtual concept. Mr. Cott articulated that in the late 70s, early 80s. Mr. Cott working for IBM in Santa Teresa, and Mr. Cott was right. So congratulations. You predicted it so many years ago, and finally we are there. And you remember what I said last year? Which system was already aggregation-free? The punch card system. The punch card system was one of the most intelligent systems in the world. And with HANA, we are mimicking the old punch card system, just with not 2,000, 4,000, 10,000 punch cards, with millions and billions. Okay, and then we can do time travel. We have active, passive data store, all things we talk about when somebody signs a contract and we start working. Is anybody signing a contract? Bill? Is somebody from California here? Metro PCS? Reel him in. Reel him in. That's an ad, television ad for Metro PCS. Next question.
Hi, good morning. I'm Steve Niesman from MyTelligence. Hasso, how does a HANA platform scale?
I said this basically, I repeat it. We have this, first of all, a reduction between hot and cold store. I take an example of a large SAP customer, 200 terabyte in the ERP system. Hot is probably 1/5 of that with data aging, so we are down to 40 terabytes. With a 2250 compression factor, we are down to 2 terabytes. We can handle this easily on this machine here. You have to really think about this. You saw the demo system. We're still debating whether it has 32 terabytes or 16. Probably we have to take the racks out and check them. 32, so he is wrong. Okay, see? And there are bigger projects coming. There's, Vishal mentioned it in passing. The Stanford University is working on a REM cloud project that all these nodes, or all these cores here inside, or all these nodes, and imagine we have 25 of these nodes here lined up, they can look from this machine into the memory of the other machines. So this thing is totally transparent. This is the Super Watson. Next question, please.
Hi, I'm Oliver Barner from Crossgate. Why is application development so much faster on HANA?
When we switched from punching cards and loading them, programming my early years in SAP, in the 1980, we switched to, we type in on the screen, we compile a program and we test the program, and it was still minutes. We are now down to seconds. End users will program on a live system with real data in business objects. They build the data access part, the algorithm with business objects universe builder, universe view builder, and then they visualize it. The easy visualization is in Business Objects Explorer, or they use Webby or any other tool, or as a second cousin, there is a complete suite of Microsoft products also sitting in HANA on top of the system, and you can interactively work. And the faster the response time is, the faster the testing is, the more cycles you can do, and the faster you can develop a product. The next is, if you extend the table, you don't have to unload, change the schema, and reload the table. You can change the schema on the fly. This is a huge advantage for developers. The next one, we do insert only. I talked about this last year. I don't want to repeat it. It simplifies the programs. A little bit more data, but it significantly simplifies the programs. And since we have this common infrastructure, we have a common infrastructure for authorization, for menu management, and so this enables different development platforms to work on HANA. And Vishal said already, we will not stop with business objects, with Microsoft's Office Suite, and the new next generation ABAP, NGAP, named NGAP. So others are invited to come and play on top of HANA. Next one, please.
Hi, my name is Lise Colroy. I'm from RioCan in Toronto, Canada, and I'd like to know, how does Business Objects integrate with HANA?
I've answered this, we have answered it the whole day. You have seen business objects working on HANA. It is just part of HANA. Next one, please.
Hi, my name is Manish Choksi. I'm the Chief of Corporate Strategy and CIO for Asian Paints. And my question to Hasso is, how does SAP refactor the Business Suite and Business Warehouse with HANA?
Referring to myself, I said this already, step by step we take over from the Business Suite. It is not a rush. The Business Suite is still the best enterprise system in the world. There's no question about it. And new customers are coming, and existing customers are expanding the reach across the components and the applications of the Business Suite. Despite that, we take things out where we can run significantly faster, provide a significantly better user experience with new business functionality at lower cost. Only then it makes sense to transfer it. Good thing is, the computer scientists in SAP figured out to transfer the BW content automatically from a BW running on a traditional relational database, DB2, Oracle, MaxDB, Microsoft, into HANA, and taking the computational part of the BW report or analytics inside the database so that we get the speed, we get automatically refactored code, we keep the front ends. If you want to change the front ends, then reuse these views and reprogram it in Excel, Microsoft Office, Business Objects, or whatever you please. All planning apps will be redesigned. I hope at the Tech Ed in fall this year, Vishal, you can have a 1.5 hour session or 2 hours if you wish. I'm not there. So I'm not there. Just to do planning. Because when customers ask me, what do you think is the most strategic thing we can do with HANA? Planning. Visibility into the near-term future and drive now the logistics and all the tactical decisions with this, based on this view you have into the future. If we have better headlights, you drive the company better. The transactional system cannot really make the company better. It's a prerequisite. But if you have better headlights, and HANA can provide better headlights. First applications we take now out of the suite is cash management, including Dunning. The first glimpse of a prototype was shown there. Work a little bit on the user interface. I said it has to be strikingly better than in the suite. Why should you switch from a suite if it's not really strikingly better? Master data management is coming, so one application after the other of the more complicated applications are coming. Most important one, Vishal, everybody I talked to, and there was a few, they said, number one, APO. And APO is coming. Why do I know this? Some of my students or my PhD candidates are working in the projects and helping with prototypes, and they tell me it will be faster. Trust us. Bill, trust. Next one.
My name is Alain Bern from Casino Group. How does HANA impact the roadmap of Business One, by design, and the suite?
I said, Business One runs productively on the Minimax, or any type of computer, but isn't it nice that a whole ERP system can run on a Minimac? That's pretty good. By design is in test. By design runs a dual mode. They use T-Rex today, one of the next versions, and it's in the cloud, so it happens automatically. You will only feel from one day to the other, probably get a note. By design is now up from today on running a little bit faster than it runs on UDB. Still in dual mode, in row store and in column store. And end of this year, beginning of next year, it will switch to column store only and will be significantly faster. Hopefully, then close to the speed we see in Business One. The suite, good question. It's not my decision. That's yours, Jim and Vishal. Technically, A1 runs since 5 months without a bug. But it doesn't run 100 times faster because the Business Suite was not designed for a columnar store. So the alternative is to use Sybase ASE. And we have to figure out which is the most cost-effective way, which is the, because ASE can run on the current equipment. It's totally compatible with a DB2 or an Oracle or a Microsoft SQL Server. NewDB needs different hardware, needs this type of hardware. So keep this in mind. No hardware change, ASE. Massive hardware change, options. No announcement yet. Next one. Last one.
Shibulal, Chief Operating Officer, Infosys. So Hasso, what new apps are possible?
We get this question every time. What are the new apps now? I can tell you it is everything at the moment, everything but massive data entry transactions. We still do transactions and workflow in the business suite. We still do shipments there. We still do packaging there. We still do manufacturing there. This is good. We're still the best system in the market. We don't have to change that. We cannot change everything simultaneously. And while Oracle is busy with Fusion, figure out how good that project is. We do the HANA project. We come from behind, give you more visibility, better decision making, probably better efficiency in the company, and keep the suite. But we have built completely new applications, and unfortunately, is still somebody here? Yeah. We run through. Static analytics, easy. We have seen dozens of those. New applications we see. We will see. Refactored applications I talked about. ASIS applications, I don't even know what that is. Oh, this is English, as is. Metro PCS. Interactive analytics, this is new. This is new. Ask a question, ask the next question. Last year it was theory, now we have it as reality. And people love it. It will change the world, how you work with data. Mobile applications, Bill, thanks that you found John Chen and his team, and they were willing to join us. Great, great company. And now after 12 years of doing mobile like Zamba dancing, we are now storming forward. And then it comes, planning I mentioned already, unstructured and text and unstructured data and structured data in one system. And it's unbelievable what we can do. How can we do this? Just remember, the name T-Rex comes from text. Vishal. Or Franz. Where's Franz? Text retrieval and exploitation? Extraction. Now, close. I was close. T-Rex was meant to be a Google killer before Google was born. Then Google came and did it differently. Just recently, the team remembered that there are actually text extractors and index builders. They still call tables inside a relational database index, which is technically wrong. They will get bad marks at the university if they talk like this. But the reality is T-Rex was a text engine builder. We reactivated this spot, and we will see in a second new applications. But let's start with an ATP demo. It is Fred Sampson from SAP. It's all yours.
Thanks, Hasso. You know, guys, we're really excited about these new applications that we're seeing on HANA, and I've brought a few of them to show you here today. The first one is this ATP product application that we've built in collaboration with Hilti. Now, this is very similar to the Avon demo that you saw yesterday, but guys, don't worry, there's no makeup in here. This one's going to be all about tools. So this is the kind of application that I would use, maybe sitting with the customer, just like you saw yesterday, to figure out which products they need and how we get them that product. So in our example today, we'll use these mechanical anchors. It's the manliest thing we could find in here. So I'll go ahead and navigate to this, and there it is. So on one screen, I have all my product information, but I also have what I need to find out when I can deliver this to the customer. And we call this process an available to promise check, or ATP check. So let's do it. I'll use this current product. Now we'll make the quantity much larger. We'll go with 10,000 units. And of course, like everything else that we do, this has to be done rush. The customer needs it in 2 days, so on May 20th, and I'll run that check. Now it'll run the single ATP check for this product. It comes back with a delivery date of June 12th. Now clearly that's not going to do. What else can we do? That was really just a one-time check. And what I want to show you now is how we take that one time and make it real time. So instead of one product, I'll select the top 3 alternatives, and I'll run the check for this. And what you'll see now is completely different. Instead of just a single date, what I get is a continuously running tally of the sales, products, orders, all in real time. You can actually see the various bars now move around as production's being scheduled, as orders are being shipped, across all the products. And we can provide this completely different view on when we can get these products to customers. Much easier to make a choice this way. And I'm actually going to hurry up because I can see the top one's going down. I'm going to buy it before it runs out. I can process the order directly from the iPad. I'll go ahead and submit that. And there's the order. It's that simple, and it's that fast. Now, how can we do this? What did we do to be able to do this? Well, we did a few things. The first thing we did is we took the raw data, not the aggregates. We brought that in memory using a very optimized data model. What that allowed us to do then is to look at the logic. Now, ATP is a very complex process. It involves production, orders, stocks, and supply. It's actually a real pain for most of our customers. So we took that logic, we streamlined it, we brought it much closer to the database, and we were able to take advantage of the massive parallelism and the power that HANA gives us to deliver this kind of performance. But that's just technical stuff. We do this to rethink the way we do processes. So what did we learn with the ATP rethink? Well, we learned a couple of things. We learned that by doing the ATP check, by doing analytics on the ATP data, not the sales data, we actually figured out which orders, what our customers were ordering, what we weren't able to deliver, and which orders we were missing out on. Let me show you what that looks like. We have an analytic that I'll bring up here on the iPad. Hopefully you can all see it. There you go, looks a little better this way. Go ahead and bring that up. All right, that takes a couple seconds to come up. What you see on this one is that we can actually see the orders, but we also get a report of all of the orders that we've missed. Now that's an absolute buried treasure, and for most of our customers, that represents billions of dollars in lost sales. With HANA, we can tap into that. We'll switch over to the PC now, and I want to show you one more thing. Now, obviously, you don't need the huge machine that Hasso showed in the beginning to be real time. Actually, the entire ATP load for Hilti will run on a single machine the size of this one. So that's enough to run Hilti's entire ATP business. However, we do have this big machine back in Santa Clara that you can see right here, and just because we can, we decided to run this ATP check on that one. And you can see, this machine is actually not even breaking a sweat. So we could probably run maybe 50 to 100 times that size business on that machine, and still it wouldn't break a sweat. So the amount of power that we have to take these businesses real time is absolutely incredible. For Hilti, this is a completely new way for them to look at their supply chain, opens up new opportunities, and they can tap into these lost sales. Now we got a couple more apps to show you. Hasso, over to you.
Thanks. You saw it? You realized it? There was a hiccup. He wanted to show that missed ATP checks, it's not available. He wanted to show how many and how this distributes so that you think backwards, oh, not these are the orders we delivered, and you run all your stats on top. The orders you missed, because that is money you lost. And it didn't work. This is live demos. Is that true? You can do it later. Believe it's where I saw it yesterday. Next one, next demo. We do something different. We do something we have never done before. We do text search and structured data in one system. Are you also doing that?
No, we're going to bring out Brian and Tom from Medtronic so we can do that demo. Hey guys, come on.
Wonderful. Come in.
Morning. It's a privilege to be here this morning. Thank you very much. My name is Tom Grooms. This is Brian Raver. And before we give you a demonstration of the text analytics that we're so excited about with HANA, I wanted to give you just a quick overview of Medtronic. It was founded in 1949 in a garage by an electrical engineer named Earl Bakken, and has now grown to be the world's largest medical device company, world's largest medical technology company in the world. And we serve over 7 million patients a year. And we do that in over 120 countries, 270 locations, and almost 40,000 employees. And we serve approximately 1 patient every 4 seconds. Our goal in the next few years is to quadruple our business and be able to serve 1 patient every second. So speed is of the essence, and in order to be able to do that, we're going to need to be able to overcome the business obstacle we have today, which is we don't know what we don't know. And that's how text analytics will help us. So Brian is going to provide us with a demonstration of what he and the SAP team have put together over the past several weeks. So Brian?
Thanks, Tom. Before we dive into what we've been working with SAP on, I want to show you first what this looks like in Explorer. This is a familiar tool, and it's a great tool. But what it doesn't allow us to do is to look at the data that's in the unstructured fields or the long text fields in our system. So this is Explorer, and you'll see that we have 30,000 records that we've loaded in of simulated data. If we switch over to the new app that we've been working with SAP on, this is our text analytics application. Again, we have the same 30,000 records, and this allows us to look at that unstructured data. For the purpose of this, we're going to take a look at a line of surgical drills that we've simulated here called Rio. As soon as I start to search and type, the system's suggesting keywords and phrases that it's already mined from both the structured and unstructured data. We'll take a look at the Rio line, and instantly we're down to 10,000 results. If we dive into one of these records, immediately you'll see that on the left-hand side we have a set of structured data like serial numbers, dates, customers. And on the right-hand side, you see a lot of unstructured data that's extremely valuable to us.
So Brian, this would be the type of information that's entered by a customer service agent as they help a patient.
Exactly. Back in the results screen, we also see surrounding the results, we have a lot of analytics that are derived from the data. This is all automatic, it's not configured. So this is also extremely valuable for helping us dive into areas that might be of interest to us. For this purpose, let's take a look at the component bearing. And you'll see instantly again that we're down to a subset of the results.
So now only 667 results. And I noticed, Brian, when you hovered even over the bar, it was updating the results.
That's correct. So if we look at the causes and simply hover over detachment, you immediately see not only the result set updating, but the analytics surrounding it. We'll go ahead and drive into worn, as we know that worn bearings can be an issue in drills. Another thing we can do is we can refine the search. So if we don't see the particular attribute that we want to drive into, we can also just go back up to the search area. And for our purpose, let's take a look at attachments. We know attachments on a drill can at times cause issues. So we'll just simply type in attachment or type half of it and it'll tell us. And again, our results are updated immediately. Another thing we can do is dive into some of the analytics in a little more detail. So you'll notice that there's a nice timeline button here, and we can take a look at whether there are any trends or patterns developing with this data.
And so, Brian, this tool is able to sense by the type of data how to structure it, and this is all being done on the fly.
That's right. So the last thing we'll take a look at is just to see if this issue that we're taking a look at with worn bearings is widespread or if it's just isolated to our simulated product family of Rio. And here you can see in the analytics that this is completely isolated to Rio. So this solution gives us a seamless combination of both structured and unstructured data along with text search and analytics, which can be very valuable to our business.
Fantastic. Now we know what next steps to take. Thank you, Brian. So while much has changed in the medical device industry, the thing that remains core to us is innovation, and that's what we see in applying SAP HANA to our business. We're very excited to work together with SAP on this project to completion. Thank you.
Thank you. Isn't that a good testimonial that HANA is not just, or the application in HANA are not just developed by SAP? The customers are developing them. We do it together. So the correct answer is, what applications do we do on HANA? We do the applications together. The old ones we do, the classic ones which come more or less from the suite, we refactor. Why should you do this? The BW, we do. The planning, we do together with you, but these are prefabricated applications. These ones are homemade, done by the team. We help, have fun with it. Hopefully we have an impact, a positive impact on your business. And now comes the next and the last one. One more?
We have one more thing to show, Hasso. I had a little surprise ready for Tom. I wanted to show them how we went now back from the unstructured data back to the structured data that we have in the system. We have a tool called C'est Bon, which allows us to navigate the complex relationships that we find between ERP objects. We took all those relationships and we put them into HANA alongside the unstructured data we got from Medtronic. And Tom, I wanted to show you what that looks like. So Brian, as I was watching your demo, I noticed that the product code AD03 actually came up a couple times. So why don't we take that and go figure out where that's from. So we'll go ahead and close out. And we'll type AD03 directly into C'est Bon. And what that does is it scans the ERP data and immediately comes up with the product record, which we can explore simply by opening it. We can get the name of the product, we can get some information as well as some analytics about it. But what I'm really looking for is this bearing that you spoke about earlier. So if I open the bill of materials, which is right here, I actually get the components of the product. I can find the right bearing, its product number, information about its stock, where it comes from. And using this tool, I can even find which other finished products we use this component in. So I'll go ahead and look at the final products. And then they are. Now this is very quick. I'm actually navigating through very complex ERP relationships to get this information. Again, today that's quite a pain to get to. And the last thing we want to look at is the supplier. So we'll close this out. And just this quick, I can find the manufacturer of this part and even get basic information about the vendor. Directly there, almost within my application.
That's fantastic. Thank you.
Thanks, guys.
All right.
Thanks.
Awesome.
I can't wait that I really can see you guys working with this dynamic navigator on real data. Instead of knowing where to go and then testing and then running through and then jumping, the system can help you to navigate. It has nearly the intelligence of a good secretary, nearly. Yeah, and that's the last one coming, probably the most interesting one. Here they are, Centrica. We switched the accent back to where it came from.
Thanks, Hasso. Hello, my name's Wayne Johncock. I'm from Centrica. We are the largest utility in the United Kingdom. And today I wanted to tell you and take you through some of the examples that we've been working with SAP on HANA. I must say hello to our friends back in the United Kingdom. SAP World Tour is taking place at Twickenham Rugby Stadium in London. So hello, London, from Orlando. At Centrica, we have in the vicinity of 18 million residential accounts, both gas and electricity. We have 1 million billion accounts, 1 million business accounts. We bill residential customers once every 3 months, and overall we manage 75 million meter reads through each year. We've got smart metering coming along. So what happens with smart metering? We will get meter reads at a much more frequent value. For electricity, it'll be once every 30 minutes. For gas, it'll be once a day. Our number of meter reads per year will go from 75 million to 120 billion meter reads per year. So that's mind-boggling within itself, 120 billion meter reads. There's going to be a lot of data that we have to deal with. Our business drivers are to understand our customers, to know what they want, to know what their needs are. With that much data, with the current standard technology, there's no chance of processing it. So luckily, we worked with SAP from an early stage. We've done the preliminary tests and works, and currently, the results we get back are fantastic for us. If I can take you to the laptop, we've got a smart meter analytic tool here. So what this does, it takes the data crunches it and gives us back some details. With so many customers, we're the largest single instance utility on an SAP system. We have so much data. If you have a look at what we've got here, we need to segment our customers. So we've got this segmentation tool. This particular one, we're looking at retail stores in London. We've managed to understand what the breakup is, what the percentage use of power is for these customers, and we can go and segregate them further. So for instance, we've got things like pubs and bars, we've got department stores, we've got small businesses here, and alone, just to do this profile shape on the right-hand side, takes a lot of processing. This profile shape, or the profile pattern, tells us what the usage is of the business over a period of time, and that's incredibly important for us to understand this. Down the bottom, we have a scatter graph. So we've got the total power consumed, we've got the number of customers, and from an executive dashboard to look at this, straight away you can see what your high value, high volume customers are. You've got your low value, low volume down here. They may be a particular business set, and you've got the scatter graph in between. And you can see how that data is changing as I move the mouse across. So this dashboard alone is a tremendous amount of processing behind it to give us this information. So taking that, how can I use that information in real life, in real time? Take a sales guy, for instance, one of our sales team. They'll have to take this information, and what we're actually doing with the smart meter revolution, we're into energy efficiency, we're into lowering the carbon footprint. We're actually telling customers to use less of our product. It's not a good business model. So what can we build on top of that? We build a service where we go and advise customers how to become more energy efficient. If I switch to the iPad, what we've got here is a smart meter app. So I just loaded that smart meter app there. It takes the data that we've worked with, and it has a look at the businesses we want to go and advise how to be more efficient in the use of energy. Here's a classic example. So I've taken the retail stores in London, which was what I just used before. Let's have a look at that. Comes up with a list of stores, and you can see them on the map there, just scattered around central London. If I take a look at one store in particular, the attributes I'm looking at are the sales per square foot, the stock we've got per square foot, what the opening hours on work days, or the opening hours on weekends. And this is quite important for us. We've got an expected value, so we've been able to crunch the data and find out what the expected usage is for this particular customer. And their actual usage in this case is higher. Hence, on the spectrum, on the energy efficiency spectrum, they're in the bottom 10%. So once we know that, we want to know what the reason for this is. So if we go and review it, in this particular case, the expected usage is the green line, the average usage at the top flow, it's consistent line. We're able to look at this and understand what the problem was. The customer was using more energy. And in this particular case, it was a bakery, and an oven was left on over this period, which was 1 day. Let's go back and have a look at another store. Same type of thing. In the bottom 10%, energy efficient, not good. Perfect opportunity for us to sell an energy service. Go and have a review of what that is. The expected tracks the average. You can't tell much from that. So have a look on the left-hand side again. We can do this hourly, we can do it by day, we can do it by month, we can do it by the type of day, we can do it by the temperature. If I have a look at the monthly usage, not much to tell there, but I can scroll back, and now I'm starting to hit May, April, March, and February. Can you see that the average usage, there's a much, much bigger difference between what the expected usage was? And that's another classic example where we can identify and sell an energy service to improve the energy efficiency of that particular customer. If I go back to the laptop, thank you. let's have a look at the energy efficiency scorecard. So that's what we did with businesses. How can we use it in the home? So again, like I said, Centrica, we've got 18 million domestic accounts. That's a huge number. For you in the home, how can you be more energy efficient? This particular customer, the actual against the expected is brilliant. Up in the green side of the spectrum, they're a very energy efficient customer. We can use this, you can post something on Facebook to say you're energy efficient. We can also use this information to go down and do a rate comparison. So once we know what their usage is, we have a history. Again, to use HANA to go and crunch the numbers here, we can have a look and see what we would map or what we would put that customer on as a good tariff to save them money. So we can go through and do a billing simulation to find out what the values should be and suggest a tariff that the customer should go on to save money. So all this is working all for the benefit of the customer to be on the right tariff, use energy efficiently, and it makes us get closer to the customer. Also here, what is quite interesting, if I have a look on the scorecard just quickly, to go back and have a look at this particular customer, we can look at building types. This is in the HANA Cloud, so I'm working in the HANA Cloud. If you wanted to see how you compared to other customers in a 20-mile radius, we have it here. Let's make it 100 miles. Press enter, goes away, does the calculation, comes straight back. So you can benchmark yourself against similar households, similar consumers in your area. The ability to crunch this data quickly, to know more about our customer, as we heard yesterday, Centrica will get close to their customers, and SAP will get closer to the customer's customers. Back to you, Hasso.
I have only one question. Why is he doing that? Why is he saving energy for me? Do you get more customers? You have only a finite amount of energy to distribute? If we do this bill, this means we sell HANA. The price is based on the size of the database, and then we come in with a consulting team to shrink it and get money and have to give money back? No. So you have to think about this. This is dangerous, what he does. Really dangerous when you apply this to our new project. Thank you very much. This is fantastic. The closing remark is very simple. Everything is possible. We don't know where the limitations are. Keep the suite running. You don't have to upgrade. You should upgrade if it has a business benefit for you. It's no upgrade necessary for HANA. We can live with any of the recent versions of the system. As I said, we can happily live on non-SAP data. Several testimonials were on Oracle systems. They have similar data in the system. Come on, the systems are not that different. The difference is in the fine complexities of some application. It's not that they don't have a mountain account in a general ledger data entry. So we have hopefully given you a glimpse of what is possible with HANA. Now we want to reel you in. Who starts early has the biggest advantage? I think when we look back 20 years ago when we started with R3, many of the companies, no, there are not so many left anymore, but many of the companies are still with us. I leave you now alone. Who wants to say goodbye? We can handshake here because only a few are left. Have a good time. Have a good time. See you next year. Bye-bye.